Let's do this. We're going to have a quiz tomorrow. It's the first quiz of the semester. It's over two sections, 6.1 and 6.2, both dealing with functions, right? 6.1 is dealing with different operations of functions, right? You're going to be adding functions, subtracting functions, multiplying, dividing, and 6.2 is inverse functions. So this review that I'm about to do, it's questions that are very similar to the ones on the quiz tomorrow. First type of question is going to be basic operations with functions. So everybody copy down this red f of x function, this blue g of x function, and this gray h of x function. We're going to be using these three functions on the next, 7 questions, 8 questions, maybe more. We're going to use all three of these functions over and over on the next questions. This is how we're going to review for the quiz. So let's begin by understanding the notation right here on number 1. It's not really f take away g times x, it's f minus g of x, which really means to take your red function f of x and subtract it with your blue function g of x. Okay, so the red function f of x is the variable expression x minus 2. Now you could put that in parentheses if you want, but it's not really necessary. The minus sign goes here, and we're going to subtract the g of x function from that, which is the blue one, which is 2x plus 3. So on the g of x function, it really is important to use parentheses, because if you don't, you're going to call this minus 2x, and you're going to leave that as a plus 3, which is incorrect. You really do need parentheses to remind you to distribute the minus sign. So this minus sign, it's going to change that to a negative 2x. It's going to change that to a negative 3. And the first binomial that we put in parentheses, the parentheses aren't necessary because there's nothing to distribute. So you don't even need the parentheses on that first one. But we do have combining like terms, which is the x combined with a negative 2x. That'll give us a negative 1x, or you could just call it negative x. And the minus 2 combined with a minus 3 gives us a minus 5. There's your answer for f minus g of x. So we've subtracted functions. Let's now add functions. We're going to be adding the f function with the h function. So we're going to be adding the red f of x function, adding it to the gray, sorry about the color, it's kind of ugly, h of x function. Okay, so the red f of x function, that's really the binomial x minus 2 plus, you could put it in parentheses if you want, even though it's not necessary, plus the h of x function. And what's the h of x function really? X squared. And I did put it in parentheses, but right here it's not even necessary. Why? Because the plus sign, if you put it in front, it's not going to change anything. If it were a minus sign, yeah, it would change it to a negative x squared. So right here, the parentheses are completely unnecessary. What we really have is simply x minus 2 plus x squared. That's your answer, but it's out of order. It's not in standard form. You want your highest exponent term all the way down to your constant, right? So you have x squared first plus x minus 2 at the very end. That's the answer for f plus h of x. So far we've subtracted 2 functions. We've added 2 functions. There's more. We're going to be multiplying 2 functions and dividing 2 functions, right? We're still using the same 3 exact functions, the red f of x, the blue g of x, and the gray h of x. This notation right here, f times g of x, that's saying that we're going to multiply our f of x function, our red f of x function, multiplied by our blue g of x function. So the f of x function is really x minus 2. And since I'm multiplying, I'm definitely going to use parentheses right here, times the blue g of x function, which is 2x plus 3. Let's do some math here. Let's distribute. X times 2x is 2x squared. X times 3 is 3x. Negative 2 times 2x is negative 4x. And negative 2 times 3 is negative 6. All we need to do now is combine like terms. Those middle terms, you could combine them. Your final answer will be 2x squared minus 1x minus 6. There's your answer when you multiply the f of x function with the g of x function, which could also be read as f times g of x. Over here we have f divided by g of x. So what are we doing? We're going to be taking the f of x function and dividing it. Could do it as a fraction. A fraction bar is really a division. Dividing it by the g of x function, which is a blue function. Okay. So up on top, what we really have is the binomial x minus 2. And on the bottom, we have that binomial 2x plus 3. And once you have your fraction, you need to see if you could cancel anything out, right? Could you cancel anything out? No. Why not? Because there's addition and subtraction going on, right? That's why we try to factor it. You try to pull out a GCF, or maybe if it's a quadratic trinomial, you could factor it to a binomial times a binomial. Once you have multiplication, then you could cancel. Right here, there's nothing to factor, there's nothing to cancel. That's your answer right there. But if you just put that on your answer column, you only get half credit. Why is that? Because you also need to state, if you ever have a variable in the denominator of the fraction that's your answer, you want to state the value that would mess it up. Okay, and what number would make this whole thing become 0? Negative 1.5. Good. Now some of us see that by using logic, right? 2 times negative 1.5 would give us negative 3 plus 3. But the fact is, it doesn't matter how complicated this denominator is, you could always just rewrite that denominator and actually set it equal to 0. That way, when you solve it, you'll find that value that will make it 0. Okay? So if you do set it equal to 0 and solve, check it out. I'll get 2x equals negative 3. And if I divide by 2, x cannot be negative 3 halves, which is negative 1.5 that you guys were saying, right? So this is what x cannot be. So here's my answer, but I want to say x cannot be negative 3 over 2, or negative 1.5, or negative 1.5, whatever you want to call it. But x cannot be negative 3 halves, or negative 1.5. Why not? Because if you did have a negative 3 halves here, the 2's would cancel, and negative 3 plus 3 would be 0, and you can't have 0 in the denominator. That would make it all undefined. So sometimes it's very obvious to see what value would make it 0, right? Like imagine if that 2 wasn't there. If it just said x plus 3, x cannot be what? X cannot be negative 3, okay? But if you do have something a little bit more complicated like 2x plus 3 and you can't think of it, you can't find out what that value is that would make it 0, go ahead and set this equal to 0 and solve, and this is the answer that x cannot be, okay? Any questions on that? So to get full credit, you need to write this answer, and you also have to state that x cannot be negative 3 halves, okay? Now, of course, if you didn't have the 2, if it were just x plus 3, you would say x cannot be negative 3. But because you have a 2 out here, you set it equal to 0, find out that answer, negative 3 halves. State both of them to get full credit. Let's move on. So far, we've added, subtracted, multiplied, divide different functions. Let's actually plug one function into a different function, all right? So let's understand what number 5 is asking us. And again, we're still using the same 3 functions, f of x in red, g of x in blue, h of x in gray. So they want us to take this f of x function, the red one, the x minus 2, and plug it into my g of x function. Okay? So let's take that g of x function, let's rewrite it. 2x plus 3. That's the g of x function. Right? I want to plug my f of x into my g of x. Here's my g of x. Let's plug in the f of x, which is this red one, right in here. So in there, I'm going to write the x minus 2. And then I have to simplify. So let's distribute 2 times x, 2x, 2 times negative 2, negative 4, 2 times, oh, no, I'm sorry. Then bring down the plus 3. Got a little carried away with the multiplying there. What do we have left? We have 2x minus 1 as our final answer to g of f of x. G of f of x. And now let's go to number 6. They want us to take the g of x function, which is the blue one, and plug it into our h of x function, which is the gray one. Okay? So let's take the g of x function, which is the blue one, and plug it into the h of x function, which is the gray one. So the gray one really is x squared. And what am I going to plug into the h of x function? The blue one, which is the 2x plus 3, right? 2x plus 3. Now right here it's a little bit more fun because if you have a binomial squared, the way to do that would be to write it twice. 2x plus 3 times 2x plus 3. Oh, it's an ugly 3, I'm sorry. But 2x times 2x is 4x squared. 2x times 3, that's positive 6x. 3 times 2x, another positive 6x. And 3 times 3, that's 9. Combine the middle terms, you get your final answer. H of g of x is really 4x squared plus 12x plus 9. Ta-da! Easy peasy. Well, it's not easy, but, you know, it's not difficult. So we've added fractions, we've divided fractions, we've multiplied fractions, subtracted fractions. Why am I saying fractions? Functions. I should be saying functions. We've done all these different operations with functions. We also are going to be asked to plug in numbers into our functions and then plug in that answer into other functions. What do I mean by that? Check out number 7 right here. I have f of g of negative 2. Now these are fun to do like in your head, right? I don't recommend that. As a matter of fact, on the quiz, I need to see work for you to get credit. But could somebody look at number 7 and figure out what the answer is in your head? Negative 1? Negative 1? 2 people say negative 1? Yeah? You guys agree?
No, negative 3.
To be honest with you, I didn't do it. I don't know it. I haven't done it yet. Negative 3? Negative 1? Okay, how about this? Let's go to the actual work here. That's why it's important to show our work, right? They want us to take this negative 2 and plug it in where? Into the g function, right? So I'm going to plug in negative 2 into the g function. So I might as well show my work here. G of negative 2, that's going to be plugging in the negative 2 right in there, this guy right in there into my g function. So negative 2 right there. So what do I end up with? 2 times negative 2, that's negative 4. Negative 4 plus 3, that's negative 1. So g of negative 2 is really negative 1. You guys agree with that, right? Mm-hmm. So here's g of negative 2. So instead of g of negative 2, let's replace it with the answer that we know is negative 1. So we really have f of negative 1. So plug in negative 1 right in there. And yeah, negative 1 minus 2 is negative 3. So we have the x minus 2. Plug in that negative 1 that we just found. So yeah, negative 1 minus 2 is the answer that most of us said, negative 3. So once again, just to reiterate, take that negative 2, plug it into g, get an answer. Take that answer, plug it into f, get your final answer. Yay? Oh, scary. Sorry. Okay. Number 8, in your head, what's the answer?
21.
What?
21.
21. Anybody agree with that?
Yeah.
Yeah? 2 people?
Yeah.
Only 2? 3? 3 people say, yeah, it's 21. Okay. Now, let's double check that. Again, the thought process, take negative 3, plug it into h, which is the gray one. What's negative 3 squared? 9. Take 9, the answer 9, plug it into the g function. 2 times 9 is 18. 18 plus 3 is 21. That is correct. Showing my work, you're going to plug in the negative 3 right into the h function. That's h of negative 3. So plug in negative 3 into the h function, you will get positive 9. So what you have here is g of positive 9. So you're going to take your g function, which is 2x plus 3, and write it 2x plus 3, but you're actually plugging in that answer that you got, 9. So you really get 18 plus 3, which is what you guys said, the answer, 21. So we've added functions, we've subtracted functions, multiplied functions, we've divided functions, we've plugged one function into another, we've plugged in a number into a function, got an answer, then plugged it into another function. Could it get more fun than that? The answer is yes. Check this one out. Oh yeah, fun stuff. I don't recommend doing this in your head. Right here, what they're telling you to do is to take the function f of x and plug it into the function g of x, and then plug it into the other function h of x. So they want you to take your red f of x function, plug it into your blue g of x function, and then at the very end, plug it into your gray h of x function. So let's begin with f of x. So what is f of x? X minus 2. So I need to plug that in where? Into my g of x function. So my g of x function is 2x plus 3, and I'm going to plug in the red x minus 2 right in there. So when I distribute, I have 2 times x, that's 2x. 2 times negative 2, that's negative 4. Bring down the plus 3, that'll be 2x minus 1. So far, I have this g of f of x, that's really 2x minus 1. So we could rewrite this now as h of that green 2x minus 1. And let's plug in that 2x minus 1 into the h of x function, the gray h of x function. So the gray h of x function is simply x squared, and we're plugging in that value 2x minus 1. In order to do this, you're going to have to write that binomial 2 times. 2x minus 1 times 2x minus 1. Distribute carefully. 2 times 2x is 4x squared. 2 times negative 1 is negative 2x. Negative 1 times 2x is another negative 2x. Negative 1 times negative 1 is positive 1. Your final answer to this whole thing over here is going to be, 4x squared minus 4x plus 1, just like you said, Michael. Good job. So we've done all these different operations with functions. We also need section 6.2. What was 6.2? It starts with the I. Inverse functions, right? And we actually start out with something very basic, finding the inverse of a set of coordinates. Ridiculously easy right here. What's the inverse of these coordinates right here? What's negative 3 and 7. Second one, 5, 2. Last one, 6, negative 4. All you do is switch your x's with your y's. To find the inverse of a set of coordinates, all you do is go to each coordinate and switch the x's and the y's. That's like a free point on the quiz tomorrow. Seriously, whoever gets this wrong, I'm going to slap you. I'm just kidding. That's impossible, right? I mean, I'd get fired. I won't do that. That was a joke. Nobody laughed. Okay. There you go. Thanks. Appreciate that. We are also going to have to find the inverse of a function, not just coordinates, right? The inverse of a function. Now, the function might be called f of x, it might be called g of x, it might be called h of x, q of x, r of x, whatever. First of all, begin by making it look like y. So if it's a f of x, make it a y. If it's a g of x, make it a y, right? And once it looks like this, again, so if you did have f of x, just change the f of x to make it look like a y. Okay, once you have it looking like this, how do you find the inverse of that function? Switch the x and the y. That's step 1. Switch the x and the y. Switch. And then what?
Cancel 2.
Okay, and then solve for y. Yeah. So let's first write it new, but switched. So instead of y equals, it's x equals. And it's 5. Instead of x, it's 5y. And then we have the minus 2 at the very end. So we have switched x and y. Now let's solve for y by adding 2. That's right. And what you do to one side, do to the other side. You can't really add x plus 2, so you're just going to rewrite it. And your final step will be what? Divide by 5. Divide the whole thing by 5. And there's your answer, y equals x plus 2 over 5. Now, the correct notation, if it started with the f of x, then go ahead and write the inverse notation. It's f with that little power of negative 1. Even though it's not a power of negative 1, it's just the notation. This reads the inverse of f of x. So the inverse of f of x is x plus 2 over 5. This is the correct answer. There's another perfectly acceptable answer also, just as correct, maybe even nicer looking, where you take the denominator 5 and split it to each of the terms, to the x and to the 2. And technically, there's an invisible 1 in front of the x. So if you did take this 5 and split it to each of them, your inverse answer would look like this. It would be 1/5 with an x plus 2/5. So either one of these is totally fine. Either one of those, 100%, A plus. Okay, now on the quiz tomorrow, I will give you a function like this, and I'm going to give you a graph. And you guys should be able to graph this, right? And I'm also going to ask you to graph its inverse. So the easiest way to do this is to simply get the graph of the original, right? The original one, it crosses at -2 on the y-axis, and you go up 5/1, okay? Might as well draw a sketch of that. So here's crosses at -2, and then it goes up 5/1. So this is really ugly, I apologize, but this is the coordinate 0, -2, and 1, 3. So if you were to graph the original y equals 5x minus 2, it crosses at -2, you go up 5/1, so you end up with this red line right here, going through those two dots. And I will ask you to graph the inverse of this guy. So it's as easy as this. Just pick 2 points on the line and switch the x's and the y's. So instead of the coordinate 1, 3, you're going to go to the coordinate what? 3, 1. So you'd have this dot right here. And instead of the coordinate 0, -2, what are you going to go to? -2, 0. So that'd be -2 on the x, 0 on the y right here. So this would be the graph of the inverse. And that really is a reflection over the y equals x line. So if you drew the y equals x line, that dot gets reflected over here, this dot gets reflected over there, right? So I guess the explanation that you could give to somebody visually is that one line or the graph will get reflected over the y equals x line, but the easiest way to do it is to graph your original one, take 2 points and just switch the x's and the y's, get your new x and y's, and then just graph your line. So there's going to be one question like that on the quiz, and we're down to our final section dealing with inverse functions. I'm going to give you 2 different functions, f of x function and a g of x function, or h of x and q of x, whatever names are. But I'm going to ask you to verify if they are inverse functions. So we have an f of x function here and a g of x function here. The only way to verify whether they are inverses of each other, whether they're inverse functions, is to plug one into the other. So f of g of x. And also, you got to do it the other way around. You have to go g of f of x. And when you do both of these, both answers have to simplify down to just x. Okay? They have to both simplify down to just x. If they do not, if you plug it in and you end up with 2x, then you could just stop right there and say, no, they're not inverses of each other. Or like, let's say you plugged in g of x into f of x and you end up with like an x plus 3. It's not just x. You had a plus 3. You could just stop right there and say, no, they are not inverses of each other. But if you plug it in and you simplify it and it equals x, plug it in, simplify it, and it equals x, absolutely both of these functions are inverse functions of each other. So let's plug in one into the other. Let's plug in the g of x into the f of x. So I am plugging in the blue one into the red one. So my red one reads 5x minus 5. I put 5 parentheses minus 5, and I'm plugging in, once again, the blue one into the red one. So the blue one goes into the red one right in here. So in those parentheses, I have the 1/5 x minus 1. And let's do some math here. 5 times 1/5, what's that? 1, right? And you have an x, so that's just 1x. So far, so great. How about 5 times -1? -5. Bring down the minus 5. Do these guys cancel out? Unfortunately, no. So right there, you could just stop. Are these functions inverse functions? No, they're not. Why? Because in order for them to be inverse functions, you have to get just x and you have to get just x. And that obviously did not happen right here. We ended up with the x minus 10. Those are not inverse functions. Okay? So it's actually nice when it doesn't end up with just x, because you could just stop and just say no and you're done. Now, if you would have gotten x, that's not enough to just conclude that they're inverse functions, you also have to do it the other way around and make sure that it also gives you x over here on this side. And that's it, guys. These are worth 2 points each because it's really like 2 questions in one. You're plugging in f of g of x, and you're also doing g of f of x. But that's about it. That's your whole quiz for tomorrow. They're not the identical questions. They're very similar. I would review this whole video tonight from Edmodo or from my YouTube channel. Also, if you want a shot at picking the exact questions, I'd make sure you study your homework because I select, maybe not all of them, but most of them from the homework. I cut and paste straight from the homework. So you have 2 worksheets. Make sure they're both complete. Make sure you understand them and study them.